All right, I don't know about you guys, but I've started the class, okay? So if you don't want to learn, put your head down and you can go to sleep, okay? There are people that do want to learn, okay? So today we are going to do the inverse function of the exponential, okay, which is a log function. So I want you to get familiar with your calculator. It could be your Nbox, it could be your scientific calculator, okay? Brandon, can you sit like you're in a classroom and you're not trying to hit up on Priscilla there? Thank you. Yeah, but turn around, not for me, for yourself. Usman, stop flirting with Elim there. Get your calculator out and find where the log key is. Do you guys know where that is? Found it? Okay. Do you know what the base is for that log when it's not written? It's implicitly 10. Okay, it's implicitly 10. And then on the same key, the key below that, you will see ln. Now, ln. Okay? On the log key, take a look at the second function key. What's on there? What's the blue thing? 10 to the power of x. So 10 to the power of x and log are inverse functions. Just as e to the x and ln are inverse functions. Okay? Okay, go do this problem here then. Do log 100. What do you get, Nathan? 2. And if you did 1,000, what do you think you'll get? Okay. From here, you guys see that 10 to the power of 2 is equal to 100? Right? And remember what you told me, okay? You told me that the base here is 10, right? Implicitly, if not explicitly there. So look how you use logs, okay? You get this to this power gives you this number, gives you that number. All right? Do you understand how logs work? Yeah? Is everybody all right? Valerie? So here's the formal definition of the log function, okay? So get this down and then let's go over. Just kind of review what inverse means as well in a minute. Anybody want to try and answer that question? Anybody want to try and answer that question? How can you tell that those two functions, f and g, are inverses of each other? There are two ways, okay? There are two ways that you've learned. Back in chapter 1. Yeah, son? No, that's not what the definition of an inverse is. Anybody remember that? One was a really mathematical way. I mean, both are mathematical. One is graphical and the other one is... Exactly. By the way, you did awesome on the test yesterday. You have improved so much that I am amazed. I'm simply amazed. Sorry? You think I was what? That was cute? Do I think you are chain smoking? Cheating? No, she wouldn't. She wouldn't be. She's a chain smoker. Well, that's good. Continuing because it seems to be helping you. Anybody getting back on the inverse, Coco? Amy, what? There was a random conversation? Coco? Can you tell me why they are inverses or how you can tell that they are inverses? What? Shh. Yo, shh. Okay, kind of conceptually, okay. Get your graphing calculators out. Come on, turn on. Can you guys in Y1 graph log x? Okay. Log x. In Y2 graph 10 to the x. Right, because isn't that what I'm telling you? I've used the base A, but let's say it's 10 because your calculator doesn't do base A. It does 10 and ln. So if these are your two functions, if you graph them, how can you tell that these are inverses? Yes. Across what? Y equals x. So go put that in Y3. Okay? And you will see that is indeed true. Okay? So you tell that two functions are inverses if you want to graph them. One's going to be a reflection of the other in the line y equals x. Okay, we've done this in chapter 1. All right. Right there, as you can see. Sorry? What? That'd be nice. Surbir, dare you focus in class? Dare you? There are a couple of dares that I'm doing right now, okay, with students. Dare you work? Okay, dare you study? I'm having issues with my calc students, so there's a dare going on there. And then the dare with you guys, I dare you pay attention. I'll double dare you. I'll triple dare, yeah. And if you get a perfect score, then the dares go away. What was that, Miriam? You're going to try for it. Nice. Okay, so everybody okay on this? No, are you watching your play on that video device there that you've got on? What are you watching? My YouTube's hopefully? Yeah, of course. Okay, so here are some restrictions on what A can be and cannot be. Okay, so A has got to be a positive quantity. In other words, you never have a log to a negative base. There's nothing like log to the base of -5. Doesn't make sense. Okay. Obviously, A cannot be 1 because 1 to the x is always 1. Okay, we learned that day before yesterday. So just to talk about the notation that your book uses, okay, the book calls this the exponential representation, and it calls this the logarithmic representation. Okay, so you'll see that in your homework. Write something as a log equation or write something as an exponential equation. Okay, they'll give you two flavors of that. Yeah. Why can't A equal 1? Because 1 to the x is always 1. That's not very interesting. Yeah, well, it gives you a constant line. And that's not very exciting. Yeah, not very exciting. Okay? Okay, doing these by hand now. Notice that you can't quite do this in a calculator until we do what's called change of base formula. That I think happens on... Oh, by the way, you got my email about tomorrow, right? Okay. Well, if you didn't get my email, then you're probably not my groupie. And if you're not my groupie, I can't help you. Okay? So there's a worksheet on the website that you could print and bring to class, okay? So... this one here has got to be done by hand, okay? So you guys need to help me out on this, okay? Right. What's the answer for the first one? Log to the base 5 of 25. 2. Everybody see that? Because 5 squared equals 25.
0.
Who's that? Okay, so this be 0. Because 25 to the 0 equals 1. Now how about this one? Negative 2. Negative 2. Nice, good job. Because 5 to the negative 2 is 1 over 25. Right? Because anytime you have a negative exponent, it goes 1 over. All right, you guys okay on that? And then how about the next one? Nice, good job. Okay, 3 to the 1 is 3. All right? You guys okay on this stuff? Okay, now this is all calculator monkey business. You guys go do the monkey business. Okay? So you guys do the monkey business on this, please. Yeah? And then the last one there. Negative 0.6931. Good job. Okay? Is everybody all right? Okay. Ooh. Oh. Oh. Graph that. Graph that. Should be looking like this. Okay? Right? So what can you say about the y-axis in this particular graph? What is it? That's right, it's the asymptote. And the asymptotes for log functions have vertical asymptotes. What do you think exponential functions will have? Exactly, because they are reflections of each other, right? So if one's vertical, the other one's got to be horizontal. The way you get vertical asymptotes on logs is by setting whatever is in here to 0. So if you set it equal to 0, you can see that's your y-axis. So your y-axis is an asymptote. Yeah, whatever that is. So supposing if you had something like this, log to the base 10 of x minus 1, then you'd set x minus 1 equal to 0, and your vertical asymptote would be x equals 1. Okay? And that kind of makes sense, because what does this x minus 1 do to the original mother graph? Moves it to the right. So instead of being where it was, it's going to move in like that. Okay? All right? That's right. Okay? All right, so again, log functions have vertical asymptotes, exponential functions have horizontal asymptotes. Okay, oh my God, we're going to do all this stuff. Okay, so we're going to go real fast through this. These are gyrations. This is what? The third time you're doing this, I think. Okay, we did it with polynomials. We did it with exponential. Now we're doing it with logs. Okay, so the usual thing. Okay, left, right shift, shift up, down, Rx, Ry, scale. Okay, the same repertoire. Same repertoire. Okay, so can you guys copy these down? Okay. Right shift. No, I don't take notes. Surbir, you got right shift down? No, you want it in your notes, man, because if my TA grades the stuff and you've got 1 page of notes, and Valerie's got like 5.
Doesn't like me. I see everybody else's stuff and I win this place.
Really?
I gotta talk to your TA. Like, I'm not trying to put anybody
You're gonna jump him or what?
I'm gonna jump.
He's a senior, man.
Big guy.
Yeah, he's a big guy too.
Is it Hal?
No, it's Nathan. Nathan Sue. No, Nathan. It's not Sue. I forget his last name now. Okay, you guys got right shift down? Okay. You guys all right on this? Yes. Shift up. I should have you finish this on your own and then compare with my notes. How's that? But I don't want to go there, okay? I refuse to go into teenage heads. They're full of mush. Really. Because you guys smoke and do crazy stuff, man.